three different proportional relationships are represented by the table, equation, and graph A, B, C. And we want to order the linear proportional function, so order these three, based on the rate of change from least to greatest. So to answer this question, we need to know the rates of change from each of these three. If we don't know those, luckily we're going to go through a quick review video. A rate of change. Do you remember what we call rate of change in 8th grade? That's right, we call it slope. Nice job. So we remember that the slope was always represented by which letter? That's right, M. M stands for slope or rate of change, and it's in the equation y equals mx plus b. And our rate of change or our slope is always the change in what over the change in what? Is it the change in y over the change in x? Or the change in x over the change in y? That's right, it's the change in y over the change in x. So to help you figure out the rates of change in each of these three things, because we need to order them, I'm going to help you see that the rate of change is represented by anything that's in pink is our changes in y, and anything in green highlighter is going to be our changes in x. So if you remember from Friday, we actually talked about how to tell if a table is linear. We had to find its rate of change, and we needed to make sure it was constant. So, no surprise, we're still doing the same thing here, finding the changes in y over the changes in x. And that would represent my changes in y. And I can find the changes in x in a similar fashion. 0 to 4 is 4, 4 to 7 is 3, and 7 to 12 is 5. So that I'm going to have in green. That's my changes in x. And then our slope or our rate just tells us to make a fraction of these two. And since it's already telling us they're linear down here, we know we don't have to do all three fractions. We can just do one because it's told us this was linear. So 14 over 4. To help order these, it might make sense. This is not a unit rate, so it might make sense to simplify it into a unit rate. And to save myself time, I'm going to do that. 14 divided by 4 gives me 3.5. So what that means is, as y changes by 3.5, x changes by 1. The 1 is the unit rate. So this is for proportion A. And I'm going to box that out because when I go to order it, I know exactly where to look. In our second proportion, proportion B, we see a very easy rate of change. It's very visible. I can see my rate of change is whatever is next to the x variable or the input. So I can see my change in y must be 5 because it's on top. My change in x is 2. So my rate of change for proportion B is 5 over 2. And because we're ordering these, we want to make sure we find the unit rate. So 5 divided by 2 is 2.5. So this means y is changing by 2.5 every time x changes by 1 for proportion B. So we can already see which one's bigger. And then the last one is going to be talking about the graph. I'm going to show that up here. Let's do it up here. So the slope of the graph, well, I remember that my change in y has to do with my y-axis, and my change in x has to do with the x-axis over here. So if I want to know my whole rate of change in this graph, I find the changes in the 2 points. So I see a coordinate starting at 0 here. And to make it go to the next point, I go down 1, 2, 3, 4, 5, 6, 7. So you can see I'm creating a right triangle. My change in y was down 7. Okay, we see that on the graph. And my change in x, well, I'm at the y-axis. I go over 1 unit and I hit my point. So my change in x is 1, positive 1, since I'm moving to the right. And luckily for us, our rate of change is already a unit rate. I'm going to redraw it with no highlighter. It's negative 7 over 1, and this is for proportion C. So now I want to order these three things. So you may be saying, well, Mr. Gallucci, Ms. Guilherme, Ms. Kiley, I see this negative 7 here, and I think it's the least rate of change because it's negative. It's the smallest number. And while that's a good thought, we have to remember that the negative actually just tells us the line's going down. It does not tell us how fast it's moving. So this is actually moving the greatest rate of change. So I'm going to fill that in because it's the biggest number. It's moving. Y is changing by 7 every time x is changing by 1. And if we look here, y is changing by 2.5 every time x changes by 1. Y is changing 3.5 every time x is changing 1. Our 7 is the biggest number, even though it's negative. To continue, I can see that between these two, proportion A is bigger. So I'm going to put that in the middle block here. And by process of elimination, proportion B must be the least rate of change. So it will go in the first box. And we are complete. Any questions?